What's going on, everybody? Welcome to part 6 of the ML and deep learning with the Halite 3 challenge tutorials. In this video, we're just going to continue building on the last one, which I believe I left off fixing a slight bug that we weren't able to train for multiple epochs. So let me quickly bring up TensorBoard. TensorBoard logdir equals logs. Dang it. TensorBoard logdir equals log slash. And for some reason I get a bunch of this. I think it's because we're kind of overriding the steps with my crappy way of doing things, but we'll get through it. So then I found that the best way to get there is with localhost :6006. If I use like 127.0.0.1, that doesn't work. And if I use the machine name :6006, that doesn't work either. So anyways, this is what's working. So let me just smooth these quite a bit. So the red line is 3 whole epochs. The orange and blue is just 1 epoch. I'm going to switch these to relative so you can kind of see those compared. But really after 3 epochs, really, maybe it slightly comes up, or at least it levels out in the in sample, but then at a sample, not too impressive. I have to switch it to relative to show you the epoch valac, though, again, because of the way that we're doing things. So again, the orange line is actually only 1 epoch, the red line is 3 epochs, and the blue line is 1 epoch. The only difference is the orange line was the time when we actually had to load the data and prepare it, whereas these two down here we didn't. So as you can see, preparing the data takes like 3 times as long. So anyway, accuracy somewhere between 24.5% and 25%. That's pretty good considering, random choice would be 20%. And in this case, we've trained a model off of, using a threshold, sure, but we're training off of models that are moving randomly. So the fact that we got, 4 to 5% over random is actually pretty impressive. That tells me our threshold probably worked, but now it's time to find out. So now we begin the massively iterative process where we've trained a model. Now we want to run a bunch of games with that model and some threshold. And then the hope is that our average or our mean kind of Halite collected has gone up a little bit. Any little bit will help, especially in these earlier games. So what I'd like to do is, first of all, let's go ahead and just copy training data. In fact, I figured that'll take too long. What I'd like to do, let me just delete this. We'll just call this training data, and I'm going to call it _1 just for the first set. And then we'll make a new folder, call it training data. Now that's empty. And then we can run those stats that we did, where we do the histogram, but also just like the mean and all of that. We can run some stats and see, has the model actually improved at all? We also could do the model versus the random and see which one wins more often or something like that. But anyways, what we shall do now is implement the AI rather than random in Centibot. So I'm going to copy paste Centibot, and now that's just Centibot, and then it'll be dash, not NL, it'll be dash ML. Okay, let's pull that up, and I am going to just close everything else. Cool. All right, so we have to make a few imports also because of the way, like Halite uses standard error and outputs and stuff for the, the game and Python to talk to each other. So we have to make sure we silence all that stuff. So I'm going to make a few imports here. I'm going to import OS. I'm going to import sys. We're going to say standard error equals sys.std error. And then we're going to say at sys.std error equals open os.devnull with the intention to write. And then we're going to import TensorFlow as TF. I hate that Sublime does that to me. Space should not, or is it space? Oh, it's because you hit enter for the new line. I don't know how you get around that actually. Anyway, sys.standard error equals standard error. So the issue is when you first import TensorFlow in, it's going to tell you things like what backend or not the backend that you're using, but it's going to tell you things about, like that's with Keras. It's going to tell you things about like your GPU and stuff like that, and we need to silence that. So this is how we're doing it, basically, to silence all that output. If you have it, the game is going to error out. So now, Centibot ML can remain the name. That's totally fine. The next thing we need to do is continue to silence any of the TensorFlow outputs. So I guess we can still write this out. I thought about just copying and pasting it, because this is just kind of cookie cutter code that was used last year to silence stuff from Halite. Anyway, os.environ, and then what we want to say in here is tf cpp min log level, and we're going to set that equal to 3 in string. And then now we want to set the GPU options. That's going to be equal to tf dot all caps GPU capital O options, and this will be per process GPU memory fraction, and we set that to 0.05. This is a small model. We don't need much memory. Why do we want to do this? Well, by default, the TensorFlow is going to allocate as much as it can and keep stuff just floating in memory to attempt to make things as fast as possible for you. The problem is this is going to exhaust a lot of power. Now the next thing is I'd like to run 3 or 4 simultaneous instances. So you have to keep in mind that at any given time up to, like, say 16 AIs could be trying to run and make predictions at any given time. So it's really important that we set this number very low. Now depending on how many you can run at any given time, given your certain CPU and all that, you can adjust this fraction, but I've actually found it runs perfectly fine, and actually it seems to run faster on a low GPU memory fraction, and I'm unsure why, but it seems much faster, like 10 times faster. It's very strange. Anyway, I think that must be some sort of bug or something that is very unintended, but definitely something I would look into in the future with a larger model even. So anyways, now we're going to set our session. Ses equals tf session, and then we're doing this so that when we load in our model, it's going to follow this session for us and use our GPU options that we set. So config equals tf.config proto, and then GPU underscore options equals GPU underscore options. Great. Now we're ready to load in our models. TF equals tf.keras.models.load underscore model, and then we give the model name. I forgot the name. And the other thing we want is random underscore chance, and I'm going to call this secrets.choice. And then in here, I'm going to say 0.15, 0.25, 0.35. So this will be a random chance that the AI will choose a random move over the model's choice. So we still want to have some exploration. Like, we can't just train models and then, because the model isn't random anymore. So we want to still have some random kind of permutations for the model to learn from new moves over time. So anyways, 0.15 would be, a 15% chance that every move. A 0.25 would be a fourth of all the moves. 0.35, 35% of the time it'll be a random move. And then every time we initialize this bot, some bots will be 35% random, some will be 25, and some will be 15. You can play with those numbers as you want. We just know that we want some random exploration involved here. The next thing I'd like to do is go into models, and let's pick... Uh-oh. Oh, no. Oh, we've made a horrible mistake. That's a huge bummer to see. We can train models pretty quickly. That stinks. Luckily, I think that model should be fine, but let me fix that in the training code. We must have forgotten F. Idiot. Shoot. Where is sent to train? It would have been, I guess, at the model save. Yeah, dang. What an idiot. So this one, it will be the 3 epoch model, which is fine. I'm not sure I would have used that one. The other thing that might be wise is to save like the score of the model. So maybe like run a model.score right before the save, something like that. Whatever. I'm going to come into here and I'm going to rename this one. Models. Hopefully, man, I feel pretty bad because I hope that's a good model. Probably what I'll do is I'll finish the code here and make sure it works. And then I'm probably going to retrain that model because I don't have faith that I didn't accidentally run train and then I stopped it or whatever after a quick, short segment. So anyway, I'm going to call this for now phase 1. Anyway, come back up to sent to train. Or not sent to train. Close that. Get out of there before we run into trouble. Come back to this script. Come to the top. In the model we want to load sent to bot ml. Where? Here. Phase 1. All right. Okay. Save the progress so far. Okay. Now, what we want to do is, I think I actually kind of want to, I just want to leave the threshold the same for now because I want to see if the mean has gone up. Like I just want to see if it's actually gotten better or not. So I'm actually going to leave the threshold the same with the hope that it actually does improve. Same thing with total turns. I'm going to leave everything the same, make the same amount of ships, all that. And instead what I want to do is I want to come down to where we actually make our choice. So choice, secrets, choice, range, len, direction, order. So what we're going to say is if secrets.choice range of int 1 out of random chance equals 1, then we want to say choice equals secrets.choice. Well, in fact, basically this. I think that's what I want. So basically, if it's 1 out of 15% or whatever, as you make that range, the question is if that number is equal to 1, then we'll make a random movement. Otherwise, what do we want to say? So else, we're going to say model_out equals model.predict. And then we want to predict, always prediction takes a list, even if it's one thing we want to predict. We need to predict the NumPy array conversion of surroundings with a dot reshape -1, and then it's -1 by the size by 3 channels. So in this case, we can say len surroundings, comma, len, it's not running over my face, nope, surroundings, comma, 3. Let me zoom out a little bit so we can see the full line. Model out predict, NumPy array conversion, dot reshape, -1 by 33 by 33 by 3. Now this returns, because you pass a list, it also returns a list. So we want the 0th element. So that's the actual prediction. Now, even though we were using scalars, it is still going to output to us a one-hot vector or one-hot array. So we want to say prediction equals np.argmax of model out. Now, logging.info, we want to save this. We're going to say f prediction, and that is going to be direction order prediction. And then choice equals prediction. So then we leave all of this other stuff. And so as we build the data is built with either our random movement or not. Just because my brain is going slow today. I don't know about you guys. Let's import, import secrets, paste this, for I in range, let's say 100. I'm going to tab this over. I'm going to print, or actually, if that equals 1, print yes. I apologize for this. I gotta make sure I'm doing this right. So we're just going to iterate over this 100 times if that is equal to 1, and then let's say random chance equals 0.5. Should be about 15 of those. Let's do 5 per, oops, 05. Should be about 5. Obviously we'd have to run just a ton, and it's random. 5, and then this should be about a 10% chance, so about 10 should be the average one we see. Seems a little low, but it's probably correct. Let's do 0.3, so this should be an average of about 30. Looks to be about right. Okay, just wanted to make sure that logic was sound. So in this case, the question is, if this is equal to 1, great. That's our 35% chance or whatever. Okay, then we model out, blah, 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 make the choice, run the game. Everything else stays the same. We're not changing any of that. So, hot diggity, let's run it. See what happens. We need to change run game, our Python version. No longer is it the one that we have. It's centibot-ml now. -ml. And probably before I make the mistake, let's just highlight one of these. Replace all. Great. Are we ready? While I think we are ready, I also think... Oh, actually, as we run the game, we'll see it. So this won't obfuscate what comes out. So, hey, let's run it. I forget if Python straight up runs what we want. It does. So Python run game.py. Let's see what happens. So on initial, shoot. I know one thing that's probably going to cause a problem. I think, let me just break this. Hold on. What did that say? Communication failed. Okay, let's read one of these. Okay, there's nothing in there, and then what we'll do is we'll go into the replays. I'll check in a second. Surely we're not timing out though, right? No. Oh, this is gonna be a huge, if you don't give me any error, this is gonna be a huge pain in my tuchus. Okay, yeah, okay, so we are timing out. Okay. I feel like I'm about to sneeze. I apologize. Fight it. Okay, so now, no timeout. So -- no timeout. Now here's a little trick. What I have found is the first time the model is loaded and the first time the model makes a prediction, it takes a little long, and then all the subsequent ones are quite fast. So for now, I'm gonna run this with a no timeout because I don't care. I'm trying to build data right now. I don't care about that. But in the future, probably what I would suggest you do to avoid that timeout is just make a BS model predict before you do game.ready. So once you've called game.ready, everything needs to happen within 2 milliseconds. So keep that in mind. But for now, let me make sure I did that. Okay, we'll set no timeout, and we should be fine. So let me just go again. I don't know why it's hanging. Okay, got it. Stupid error, but also strange. I didn't get why, like it didn't error to me. So I know we're silencing errors to some degree, but then I copied centibot.ml and I commented out to my understanding all of the things that we were doing that were silencing the output. And then I just tried to run just this and see if it would load. And it would not. So, yeah. Anyway, the issue was we wrote phase 1 in here. Well, phase 1, unless that's a directory maybe somewhere, like phase 1. No, it just doesn't exist. Phase 1 doesn't exist. So we should have gotten an error, but we weren't getting the error. So, cool. Anyway, regardless, the AI is running. We can already see here some of the outputs. I would wager I started almost immediately whenever it started running. It looks like we're actually getting quite a bit of Halite per game. We already started building some training data. Let me pull up the new training data here. So immediately I think these were the first 2 games, but we might have just gotten lucky. But it will be very interesting. Like right now, the distribution isn't quite so heavily weighted towards the 4100s, but I'll let it run for quite a while. I'll actually open up a couple more, run quite a bit. I'd like to get at least another, you want at least probably somewhere between 5,000 and 10,000 games if you want to make the fair assessment. But these take so much longer to create, so we'll see if I'll actually have the patience to do that. But I might let it run all weekend or something. But the real question is it actually better than the previous one? But as you can see here, all of these games saved because they were all great games. So anyways, once I have maybe about 1,000 games or something, I'll check the distribution and see. And if it's pretty darn good, we can figure out what threshold do we want to use and so on. So anyways, that's it. It was a pathing issue. Stupid on my behalf, but also I'm curious why that didn't come up even when I created the copy script, ran the copy script, and still, why didn't I get an error that said, hey, this doesn't exist? Very curious, but whatever. That's it for now. Questions, comments, concerns, whatever, feel free to leave them below. Otherwise, I'm going to see you guys in the next video where we just basically we'll check the distribution here and then continue that iterative process and just kind of, I don't know what I'll do in the next video, if I'll maybe already do the iterative process. I don't know. Or maybe the next video we'll talk about the changes and then from there do the iterative process. Because basically after, at this point, nothing new happens really. At some point we want to add more ships and we want to change the threshold and all that. Yeah, in my opinion, this AI is way better. I mean, we don't have a 5,000 game yet, but look how few of them are at the 4100s. Almost instantly we're in the 42s and up. So I would hazard to guess this is a significantly improved, but we'll see just by how much in a while. Anyways, that's all for now. See you in the next video.